Dear learners, in this video I am talking about traveling salesman problem. At the end of this video, learners will be able to solve the traveling salesman problem. Traveling salesman problem deals with creating ideal path that a salesman would take while traveling between cities. The solution to any given traveling salesman problem would be the short way to visit a finite number of cities, visiting each city only once and then returning to the starting point. For example, a businessman, he wanted to travel from Mumbai, Delhi and Calcutta. So the time between these three cities has been given in this diagram. So Mumbai to Delhi, if you want to travel, it will take 7 hours, and Delhi to Mumbai 15 hours. In the similar manner, between the all cities, the traveling time is given in terms of hours. Now I need to minimize and optimize in which path the salesman or business person need to travel. And in order to solve that, I will keep this data in a table form, in the matrix form, and because the D here, the D represents Delhi, M represents Mumbai, K represents Kolkata, and Delhi to Delhi there is no need of traveling, so it is need not to allocate anything. So that is why this is represented in terms of infinite, and Delhi to Mumbai it is 15 kilometers, so it is 15 hours, so I will be writing 15. Delhi to Calcutta it is taking 10 hours, so I will be writing 10. Then in the similar manner, from Mumbai to Delhi 7 hours, and Mumbai to Mumbai it is not actually need to allocate, so it is represented as infinite. So by addition or subtraction it will be always infinite only. And Mumbai to Calcutta 9 hours. The similar manner, from Calcutta to Delhi 15 hours, Calcutta to Mumbai 12 hours. Now in order to solve this, I will be applying Hungarian method in order to assign and get the optimum solution. So according to Hungarian method, if I first I need to identify the column row minima and subtract all the elements from the minimum value in the respective row. So here in the first row the minimum value is 10, so if I subtract the infinite minus 10, infinite always will be infinite, so it will be infinite, and 15 minus 10 5, and 10 minus 10 it becomes a 0. The similar manner, in each row the minimum value if I subtract, I will get this matrix, because I got 1 0 in every column, so even if I do the column operation, I will get the zeros in the respective, I will get the same values. Now I wanted to allocate, and if now the salesperson, let us say he wanted to start from Delhi, so Delhi to I am just allocating 0, Calcutta. So and then Mumbai to, and 0 is at first column, so I will be allocating this 0 for Mumbai, and then Calcutta to Mumbai again. So this is how the solution has been given. So now if I want to see how he is traveling, so he is starting his journey from Delhi to Calcutta, and again from Calcutta to he is traveling to Mumbai. From Mumbai again he is coming to Delhi. That means where he is starting the journey, there he need to end his journey. So even if he is starting from Mumbai, he will go to Mumbai to the Delhi, and the Delhi to Calcutta, and Calcutta to again Mumbai. So in that sequence he will be traveling, and in that way it will give the minimum the time. So if you see here, the traveling route will be the Delhi to Calcutta, Calcutta to Mumbai, and Mumbai to Delhi again. And the traveling time is 10 plus 7 plus 12. So this is the total traveling time. The similar manner we can solve any number of problems. So let us see one more problem, which is a 4 by 4 matrix. A salesperson must visit three client location B, C, D in different cities and return to the starting city A. The matrix provides travel time in hours between cities. Find the fastest the possible travel route to minimize the total business trip duration. So here also we need to solve this travel salesman problem. So if you apply the travel salesman problem, so and solve the problem by Hungarian method. So if you the row operation if you do, and because the first row 6 is the minimum value, and if you subtract all the elements from the row, it will be the first row you will get it. In the similar manner, the row B, and 4 is the minimum value. If you subtract all the elements from 4, then you will get the second row. And in the similar manner, C and D, if you subtract, you will get the fourth row. Then if you do the column operation, in all the columns zeros are there except first column. The first column minimum value is 1. If you subtract all the elements from the minimum value, then you will get the 2 more zeros in the first column. So then if you draw the horizontal lines to cover the then you will be allocating, and you will get a minimum 4 lines. So if you allocate A with the first column with C, and second column with B, and fourth column with D, A, and then B will be with the D. So finally, so if you see this allocation, then the salesperson, he is starting his journey from A, and A to C he is traveling, and from C again he is traveling to B, and from B he is traveling to D, then finally from D he is coming to A. So that is the route, and the minimum travel time will be 6 plus 3 plus 4 plus 5. So it will be 18. So this is how these traveling salesman problems will be solved. But here one of the important things we need to remember, steps involved in Hungarian method. These steps we already discussed in assignment problem, and these 5 steps we need to remember in order to solve and apply this Hungarian method for salesman problem. So here the first column operation, row operation, column operation, then drawing the minimum horizontal and vertical lines. If the horizontal and vertical lines are equal to the number of rows, then we can assign the solution or assign the task. If not, we need to do some more iterations by following the step 5. Then let us solve one more problem, that is 5 by 5 matrix. A municipal waste management team is planning an automated garbage collection route across urban areas. The matrix provides distance in kilometers between collection points. Find the optimal route that minimizes the total travel distance of the garbage trucks. So A to E, there are some areas where they need to collect the garbage. We need to find the optimal route. So now this also we will be solving in the same manner. If you apply the Hungarian method, the column operation, if you row operation, if you do, this is the matrix we will be getting. And if you do the column operation, so you will be getting the same matrix, because every column it is having 1 0. So now if you draw the horizontal line and vertical lines, there are total 5 lines are there. That means we can able to assign the jobs. So now if you assign, so you identify the first row. In the first row there is only 1 0. So that is why we can able to assign that 0 to A. And then the second row there are 2 zeros. So that and 1 0 already cancelled. So the second 0 we can able to assign. And the third row only 1 0 is available, that we can able to assign. Similarly fourth and fifth there is only 1 1 0, we can able to assign. Now if you see the sequence or the routing, so the routing is starting from A and A to E. So the salesman person or the truck, it is starting from the location or area from A and it is going to E, and from E again it is coming to A. That means without covering B, C and D, it is coming to A. That is not solving our purpose. So our purpose is the truck should go to each and every area and collect all the garbage. So that means here if you want to find the optimal the route, so this is not how we need to follow. Then we need to change the allocations. Now already according to Hungarian method, we already reached the number of lines are equal to the number of the rows. Number of lines are equal to number of rows or column. So then we can't do further iterations. So what we should do here? So here, because if you get some extra zeros, we can able to see is there any possibility to get another allocations. But here almost all the zeros except 1 0 has been already assigned. We don't have extra zeros. In order to create extra zeros, we can take a minimum value and subtract all the unallocated the columns. But here the problem is already we reached the number of lines are equal to number of rows. So we can't further apply the Hungarian method. So here we need to without applying the Hungarian method, we need to identify the smallest element in the entire matrix apart from 0. So apart from 0, if you identify all the elements, the smallest element is 1. So in order to get another allocation, we will be starting the allocation from the minimum value. So the minimum value here is at AB, that is 1. But this 1 is there in other places also. But first we will be starting from the first one, which is available at AB combination. So then if you start from there and if you select this one first, then we can able to avoid that column and that row accordingly, and then we can able to assign the task. Then you go to second the row, so there are 2 zeros, and third row there is only 1 0. So then we can able to assign, and then if you go to fourth row, there is only D, the D row, and there is only 1 we can able to assign, because 0 already it has been cancelled. Then if you go to the first column, and that is only one 0 is there in that column, so we can able to take that assign that 0. Then now we got if you see the route from the first area A to up to till it should come to A. So the traveling person or the truck, it will start from A, and it will go to A to B, from B to C, and C to D, D to E, and finally from E to A it will come back to its the starting position. So that is how we are going to solve. But here we need to remember that whenever whatever the zeros we allocated, if that is not giving a optimal route, and then we need, in that case only, we need to consider the minimum value apart from 0, the next to 0, what is the minimum value that we need to identify, that we need to assign. But here you may ask another question. So now we have selected A, B, 1, and there are three more places 1 is available. So even if you select the D, E, 1, still we get the same solution. And if you select the 1 which is in the 4th row, then we could not able to get the again another route, the optimum route that we can check. So that is why we need to follow the first route. So then whenever there are 3-4 options are there, 3-4 ones, or maybe 3-4 similar small elements, then we need to check answer with each and every element, and then we need to see whether it is giving the optimal path or not. So here also we first start the solution with A, B, where 1 is starting, and if you recheck with E, B and E, C, we will not get the optimal solution. So that is why we need to the first we need to first check that. So then if you get the solution, finally we are going to get the 13 kilometer is the optimal distance. So now if you go so let us see one more problem. So the fourth problem. So the fourth problem says a company produces goods in 6 factories and need to transport material between them efficiently. The matrix represents transportation cost in rupees between factories. Determine the most cost effective supply chain route to minimize logistic expenses. So here this matrix is 6 by 6 matrix. So here also we need to minimize the cost. So how to solve this the problem? So even it is 6 by 6 or 7 by 7 or 10 by 10 matrix, we need to follow the same sequence. But as the number of columns or rows are increasing, it will also increase the complexity of the problem. So if you solve this problem, so fourth problem, so first you do the column row operation. After doing the row operation, so if you observe the first column, there is only 2 that we need to do column operation again, and then again the column E, there is no 0, so we need to do column operation there. Then according to Hungarian method, again you draw the horizontal and the vertical lines. So here there are the 2 zeros, here also there are 2 zeros. You draw horizontal line and vertical lines such that we can able to get the minimum number of lines. So if I draw the horizontal and vertical lines to get the minimum number of lines, I am only getting a 5 number of lines, but I have 6 unknowns or 6 rows. So the number of lines are not equal to number of columns or rows. So I need to do the fifth step. The fifth step says whatever the unallocated the elements are there in the matrix, which are uncovered elements are there in the matrix, that matrix need to subtract from the minimum value, and at the intersections I need to add the minimum value. So here in this matrix, the red color, some of the elements are given. These all red color elements are not covered with the horizontal or vertical lines. but there are some the intersections where the green color numbering are given. So there we need to add 3, the minimum number at the junctions, that is 3. So if you do this iteration, then the new matrix we get is this. So now we got some extra zeros because there is a value 3 which we need to we subtracted. So if you now draw horizontal and vertical lines in order to cover the zeros, now I am getting the total 6 number of lines. That means I have 6 columns and the 6 number of lines I got it. So finally I achieved the number of lines are equal to number of the rows. Now I can able to assign it. So now if I want to assign it, you go to first row, and in the first row there are 2 zeros, I can't assign. Second row there are 2 zeros, but third row there is only 1 zero, that I will assign. And fourth row 2 rows, 2 zeros. The fifth row there is only 1 zero. And now if you come to column, the first column 1 zero, and the second column, and there are 2 zeros, and then the third column there is only 1 zero, but that is already selected. And then the second column, already the column C 0 is selected. So the first AC 0 is selected. So in column B the DB 0 is selected, and now one more 0 we can able to select in a fifth row. So that is the only left. So here actually I selected these elements in such a way that I get the minimum cost. So here I can able to select there are 2 zeros in first row, and any one I can able to select, but wherever I get the minimum value, that I will select it. So in that way I have selected it. But now if you see the routing, so if you want to see the routing, so it will first go to A to C, and then C to D, from D to B, and B to A. That means without covering E and F, it is coming back to A. So then in that case there is a procedure that we need to first see what is the minimum value after 0. So in the entire matrix, so the minimum value after 0 is only 2. So that is at 2 places we can able to see 2, and then you first assign that 2 for allocation, that is first row, the fifth column, that 2 you will assign, and then we can able to assign the remaining the elements as usually with the 0 elements. Then if you go to the second row, there are 2 zeros, third row there is only 1 zero, then the fifth row 1 zero, column because the first 0, the second column first 0 is already cancelled, so the only the fourth 0 is allocated. And then if you see the second column, then we can able to assign the 0 because there is only 1 0 in the F row. Then finally this is the allocation. So now if you see the route it will start from A, and the vehicle or the travel salesman person will start from A and he will go to E, and and from E again he will be starting and he will go to F, and from F he will be reaching to C, and from C he is going to D, from D he is going to B, from B he is coming back to A. That means he is covering his the journey. So the total minimum distance, if you see, it will be 103. So in this way, even if it is the 5 iterations, we can able to solve this problem. So let us see the last problem, which also we can able to solve. A fleet manager need to optimize fuel consumption for a delivery the truck traveling across 5 cities. The matrix represents fuel consumption in liters required to travel between cities. Find the route that consumes the least fuel while covering all cities. So here there are 5 cities. So the traveling the distance, not distance, the fuel consumption is given for traveling, so we need to minimize the fuel consumption. So if you take a first matrix, again if you do a row iteration, so this is the matrix we get, and and again if you do column operation, and we will get another matrix that is here, and because a C column there is only one the column which is do not have 0, so if you do column operation there are some zeros we will be getting. So then now you draw horizontal and vertical lines to cover all the zeros, and these lines should be as minimum as possible. That if you see there are only 4 lines, and because the 4 lines there are some uncovered elements, these uncovered elements need to subtract from the minimum value apart from the uncovered elements. So the 10 is the minimum value which is not covered and which is the minimum value, so you subtract all the uncovered elements with the minimum value, then you will get all red color, the letters, the digits has been changed here. And again there are green color digits which are having intersection, there we need to add 10. So if you add 10 you will get this matrix. Now if you draw horizontal and vertical lines, then we can able to see there are 5 lines, that means there are 5 unknowns, the 5 columns, and we can able to assign the elements zeros. So then if you assign, this is the this is how we are getting the route. So now if you see the route, so it is traveling from the journey start from A to D, and again from D to B, and from B to A. That means without covering C, it is coming back to C and E, it is coming back to A. That means this is not the ideal route. In order to change the route, we need to again follow another rule. We need to see what is the nearest value to 0. So the nearest value to 0 is the 10, or the minimum value apart from 0 is 10. So any 10, there is only at 2 places we can see 10. You allocate that 10 first. Then if you allocate the 10 first, then the remaining allocations we can do with zeros, and if you do the zeros with the other the places, then we will get the allocation like this. Now if you see the route is starting from A to D, and D to B, and B to C, C to E, and coming back to A. So now if you see the distance between the fuel consumption of these allocations are 40, 70, 60, 40 and 50. That if you total it, it will be around 260. So now you may get a doubt that you have selected or assigned BC element you have assigned. So why can't you take CA or CB? There also there is a minimum value which is 10. So even if you take a CB which is 10, then we will get the new allocation. So even in the new allocation, the salesperson is traveling from A to E, E to C, C to B, B to D, D to A, and finally the minimum fuel consumption will be the same. So from this we can say the both answers are correct. So then from the traveling salesman problem, we understood that it can be applied for many applications such as logistic and supply chain, enhance delivery route planning for companies like Amazon, FedEx, reducing cost and travel time, routing around cities we can able to apply, optimizes travel routes for taxis, deliveries and emergency services to minimize distance, time and fuel consumption, and computer wiring also we can apply, where it will reduce the wire length in circuit board design, improving efficiency, signal transmission and manufacturing cost. It can be applied for job sequencing, where it will minimize setup time in manufacturing by optimizing the order of job processing on assembly lines. Finally, it will also applicable in robotics and automation, where it will optimize the robot, drone, CNC, mission paths, routing for efficient operation and minimum energy usage. Finally, I would like to conclude that traveling salesman problem is crucial for optimizing routes, reducing cost, and improving efficiency in transportation, logistics, and manufacturing. Solving traveling salesman problem enhances decision making in supply chain, robotics, and automation by minimizing distance, time, and resource consumption. Exact algorithms work for small problems, while heuristics and meta-heuristic provides near optimal solution for large scale application. Traveling salesman problem is widely applicable in real world scenario like delivery services, job sequence, and network routing. Future advancement in AI and quantum computing may provide efficient solution for complex travel salesman problem. Thank you.